Greetings once again, students. We continue with our course in financial computing and we are concluding our lesson on MATLAB today. Let's go and talk about the functions in MATLAB. There are three types of functions, just like we saw in VBA, in C, and in MATLAB. Inbuilt functions which come as part of the software package. These we can utilize as is standard using the help function. We also can develop our own scripts. I would like to take scripts as equivalent to subroutines in VBA and or void functions in C. Then we've got the third class, which are the functions. The functions we did in VBA, we did in C. We also can do functions in MATLAB. These are user-defined functions that carry out those tasks that are not covered in the inbuilt functions or in the scripts that we have done because we want to solve a particular complex problem which does not have a standard way of solving it, and we want to come up with our own algorithm and then code it in MATLAB. On the inbuilt functions, we'll look at the financial toolbox. You can play around these features where there is portfolio optimization, risk and investment analysis, fixed income analysis and option pricing, time series analysis, regression, even with missing data, and technical indicators and charts. At your own spare time, try and explore how these features work. You may find them useful in your day-to-day work, and these are inbuilt with your MATLAB. Let's move on to scripts. Like I mentioned, I would equate them to subroutines in VBA. This is the simplest type of MATLAB program. A script is a file which is saved with a .m extension. It contains multiple sequential lines of MATLAB commands and function calls. You can run a script in MATLAB by typing its name at the command line. So we have been typing commands on the command line and we would get our results instantly when we press enter. When we are saying a script now, we are now doing a single compilation of those commands into a file which is saved with a .m extension. This file now you can always refer to it and call it and run it. If you recall, some of those commands you typed on the command line, the moment you close your MATLAB, they will go away. But if they are saved in a script file, you can always reference them. So I would say we use scripts when we have got a series of commands that we want to execute and we want to keep them saved somewhere on our computer. Let's carry out the example of doing a script which is called plotrand, which is supposed to plot a series of random inputs. To start that, you could use a command line by typing the word edit and the name of the script file you want to create. Or if you're a graphical user interface person, you can just open a blank file and name it plotrand from the file menu. There is the example of the code I want us to look at. I'll try and explain the code for your understanding. The first two lines there are comments. We learned that it is good to put comments on your code for the reader to understand what your function, your script, your subroutine is trying to do or achieve. In VBA, we had single quotes. In C, we had / and an asterisk. And now we've got a %sign showing us that the following is comment. It will not be executed by the compiler. So that is the case. We terminate statements with a semicolon. That is the same as we do in C. In that case, we want to plot a line by generating random inputs as our 50 data points. Then we draw a line from 2 points. I would like you to carry out this example by following the instructions and copying the syntax as it is. Syntax is supposed to be kept as is. You cannot then tweak it or feel like it's not properly phrased because the compiler will be lost in compiling your code. Now that you have finished doing your script, you need to save the file in the current folder and you save it with a .m extension as I mentioned before. You can run it by typing the name of the script file on the command line, or you can also run it from the window editor by pressing the run button on the menu. Let's move on to loops and conditional statements. Like I mentioned, these constructs, we're going to use them across any programming language, be it VBA, C, Java, Python, or whatever it is. In this case, we're using it in MATLAB. The concept is the same. Life is not as straightforward. There are times when you have to do conditional statements, or there are times when you have to carry out a task over and over to achieve a particular output. So you'd find that looping, which is called repetition elsewhere, or iteration, is going to be part of every programming. Same as conditional statements. You'd find that there are certain conditions to be tested before you conclude or you make a decision in solving your financial engineering problems. So here, let's look at doing these in MATLAB. We've got an example there. I would like you to copy that code and have it on your script file so that we can execute it and see how we do this. You'd find that the syntax for the for loop is slightly different in the way it is done for MATLAB than we did in the prior examples. It is the one on line 3, where we say for k equals 1, full colon, n samples. We've already defined or declared our n samples as 5. So the colon means that we are moving from k equals to 1 up to n equals to 5, and we carry out the 2 instructions that are written in there. And once we get to n equals to 5, we have finished execution of our loop. We exit the loop, and then we can compute the overall mean as in the example. Let's go on and modify our example. What I'd like you to do is to be able to display the result at each iteration. And we said that we suppress output and we do not suppress output by the choice of using the semicolon or not the semicolon. We mentioned that at the beginning of the MATLAB course. So I want you to follow the example and let's see the output coming differently after every iteration. I'm sure you are able to go through that code and you've got it right, and you're now able to display the output after every iteration as shown on the screen. Let's move on to conditional statements. These are our if statements. We can modify the already existing script file that we have by putting conditions where we want to check if the overall mean is less than 0.49, we display a particular message. If it's above 0.51, we display a different message. Otherwise, the default message to be displayed is shown. This is an example of if condition is true, then do that. Else, if the next condition is true, then do that. Otherwise, do this. This is there across all programming language. What will differ is the syntax of each language. Be in a position to carry out conditional statements across the 3 languages that we have learned in this course. Scripts are normally saved in the current folder, which is by default on the search path in MATLAB. So if you want to change that, you always have to make sure that the folder that you have chosen is added onto the search path. And there is an instruction on how you can do that. If you choose to create, say, a folder with your financial engineering MATLAB code, then that folder should be added to the search path where you're going to save all your MATLAB script files. Let's move on to user-defined functions. These are custom functions that you create because you want to accomplish a particular task. You can borrow inbuilt functions within your user-defined functions. You can compute them totally independently of the user-defined functions. A function can have more than one output and several inputs. The syntax of declaring a function is you use the keyword function, which is a reserved word in MATLAB. Then you can put your list of outputs separated by commas. Then you put the equal sign. Give it a name. The function name should be self-explanatory what your function does. Then the list of arguments or parameters which are the input to the function for processing to give you the output. This you need to master as you'll be expected to be able to create your custom functions in MATLAB. Let's do an example. We want to calculate to do a function that raises a number to the power of another number, e.g. 2 to the power 2. But you want it to be able to compute even for 3 to the power 10, 400 to the power 20. So you are going to define your custom function, which in this case, we know its output is going to be y, and the name of the function we have called power, and its input or arguments are m and n, the 2 numbers that we want to compute the power of. So that's how we declare the function as on the first line. The second line is the operation or the expression that we want to produce our output to be carried out. So in that instance, we then compute m dot, we use the power on the icon on the keyboard, n. That is how we compute the power of a number, remembering that MATLAB is about matrices, so we need the dot operator as we're dealing with vectors. Then, of course, we have the end to mark the end of our function. We had a similar case in VBA, if you still remember. But remember, we're now in MATLAB. Avoid mixing up code from VBA into MATLAB. There is a task that you should also carry out. I urge you to do it independently and then review the solution to test your own understanding. This is going to be a mixture of doing conditional statements, testing if you know how to do a function, and how to do a complete MATLAB saved file. That is the solution. I hope we had gotten it right or along the lines of being correct. There is an example of an application where we can utilize the MATLAB functions to solve real-life problems. There on the screen is an example of an Asian option. We want to simulate the price behavior of an Asian option using the standard log normal or geometric Brownian motion model. We are given the model there and also given the parameters in their explanation what they represent. What is expected of us is to be able to simulate the price behavior over time. So we are going to be expected to come up with a plot and to come up with possible values of the price behavior. We only know the price of the underlying as of today, but it's going to change over time, which is 50 days in our case, time to expiry. And we want to see the behavior taking into account the volatility of the market. So I'll give a clue on how to do it, and you can explore this at your own spare time. You need to be able to generate your potential future parts of S by running a simulation like we did in Excel or Monte Carlo simulation of 1,000 maybe. You could use the run function to get the unknown volatilities, how they'll behave over the period. Then you could plot a graph of time versus that future S that we have generated, and that is a time horizon. So in this case, we know our ending time is 50, and we keep what? Decrementing it by 1 day up to the time we get to the S naught, which is the initial time. I hope you'll be able to get this one done right. We have come to the end of our course, and we'll entertain questions and we get answers during our live session on Saturday and Sunday. Let's all plan to attend the virtual classes that we're going to do. Get your Zoom installed, get your computer ready, get all the software that is needed installed, and make sure that we are geared up to appreciate all the content that you have learned and be able to cement your understanding of this course. Thank you so much for being part of this course. We meet over the weekend.